Good morning, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with Chapter 6. This chapter, or this section, is about using proportions to solve geometry problems. So we're working with like scale drawings and stuff today, comparing a model or like a map to an actual distance, okay? So this will be useful for similarity and solving for missing lengths, okay? So let's get into it here. We have a warm-up here to solve the following proportion. We have 6 over x plus 7 equals 5 over 10. So go ahead and see if you can solve this. Go ahead. All right, so how do we solve proportions? Well, we're going to cross multiply. So let's do that. So we have, remember when you have like x plus 7 down here, we have to multiply 5 parentheses times the entire x plus 7 equals, what's 6 times 10? That is 60. All right, now to solve from here, we're going to distribute. 5 times x is 5x. 5 times 7 is 35, equals 60. Now we're just back to solving, so we're going to subtract 35 from both sides. So we get 5x equals 25. Then divide by 5. And we get x equals 5. 25 divided by 5 is 5. All right, let's keep moving along here. So a scale drawing is a drawing that is the same ratio as the same what? The same ratio as the object it represents, okay? A scale is a ratio that describes how the dimensions of a drawing, of a what? Of a drawing are related to the actual dimensions, to the what? Actual dimensions of the object. All right. So we have a couple different variations of, we talked about the cross products of proportions being equal. There's actually a couple other properties we need to know about, okay? Reciprocal property is the first one. What does it mean? What does reciprocal mean? So you can see over here we had A over B equals C over D. Then B over A, looks like we flipped this. What's the other one going to be? It's going to be D over C. We're going to flip both of them, okay? So that's one thing you can do, is you can flip proportions vertically. So, for example, if we have 3 over 2 equals 6 over 4, then we can assume that if we do the reciprocals of both of those, what would that be? That would be 2/3 equals 4 over 6. And those are equivalent ratios, so you can see that will work. Okay? Another thing we can do, so in this case, the top one we flipped vertically. We can actually flip horizontally. So you can see we have A over B equals C over D. Then A over C is going to equal what? B over D. We can flip horizontally as well. So for example, if we have 14 over 18 equals 7 over 9, then what would the new one be? I want you guys to see if you can figure it out. We flip it vertically, it's going to, or horizontally, it's going to become what? It's going to become 14 over 7 equals 18 over 9, and those are equivalent fractions. So you divide those, you're going to get 2 equals 2. Okay? All right, last one's a little weird, but it is an actual property, so we'll cover it. So we have A over B equals C over D, and if we add the denominator to the numerator, we're going to do the same thing with the other one we can do. So A plus B over B is going to equal what? C plus D over D. All right? Sounds good. So those are the big ones here. So let's just write a couple, one hint down here, okay, is you can flip proportions. You flip proportions vertically, which is up and down, or horizontally, which is side to side, but not diagonally, okay? Some people try to flip diagonally, that's the only way you can mess it up. But not diagonally, okay? So those are some properties there. All right, let's get into it here. So, example 1 says, use properties of proportions. In the diagram, AC over DF equals BC over EF, write 4 true proportions. Okay. So, well, let's go ahead and do this. So, for example, we're going to write 4 different proportions here. So let's write 1, 2, 3, and 4. Okay? So, I think it's just good to set up the original things. We have A over B fix that here. A over B equals C over D, okay? So in this case, we have AC over DF. Let's start with the original one. AC over DF, we're looking at this over here. So AC was what? Well, that was 12 over DF, which was 18, equals, then we have BC, which is 9, over EF, which is X. Okay, so this is one of the proportions, just by what they gave us. I would highly encourage you, whatever they give you to start, that's a really good way to start your proportions, okay? All right, so why don't you guys go ahead and, based on like these things we talked about up here, see if you can come up with a few more different proportions. Go ahead. Okay, so the second one we talked about was we could flip it. We could do the reciprocal property. We can flip them. So instead of A over B, we get B over A. And instead of C over D, we get D over C. So we can flip all these numbers here. These are basically the same thing. We're going to flip them. So instead of 12 over 18, we get 18 over 12. And instead of 9 over X, we get X over 9. So that would be another type of proportion. So we flip them vertically. We can also flip them horizontally. So for these ones, we can go A over C equals B over D. Okay, so in that case, that would be what? 12 over 9 equals 18 over X. All right, and that's flipping them horizontally. And the last one's kind of weird. That's the A plus B over B equals C plus D over D. In this case, this would be 12 plus 18 over 18 plus 9, or sorry, equals 9 plus X over X. And if you wanted to, we can simplify this a little bit. The 12 plus 18 can reduce to what? We can get 30 over 18 equals 9 plus X over X. Okay? That last one's going to be hard to see and kind of hard to work with, but yeah, just go ahead and make sure you kind of know what we're doing there, okay? All right, sounds good. Okay, now we know how to set up different types of proportions. Let's go ahead and use proportions to solve, all right? This next one's actually not too bad. It looks kind of complicated, but we're just going to do exactly what this says right here, okay? So in the diagram, it says JL over LH equals JK over KG. Find JH and JL. I'm going to box those. We want these, okay? All right, so we're just going to literally do what this says right here, okay? We're literally just going to do what it says. So JL, this is actually a little weird here, okay? So we have JL is this distance right here, okay? We know the entire thing is X. We know this is 2. So how do we solve? What would JL be? This is a little weird, right? So let's call this Y, right? So we know Y plus 2 equals X, which is the total. How do we solve for Y now? Well, we're going to minus 2. So Y is going to equal X minus 2, okay? So does that make sense? If the whole thing is X and that part's 2, then the rest is going to be X minus 2. Okay, it's a little weird, but that's a good way to kind of figure it out. So we can do JL is going to be X minus 2 over, and then we have LH, which is just 2 like we talked about, equals, and then we want JK. In this case, JK is 15. We have 15 over, then we have over KG, which is 5. Okay? So now what we have here is we have a proportion, and now we can go ahead and we can solve by our proportion by doing what? What do we do to solve proportions? We cross multiply. So we're going to do 5 parentheses times X minus 2. What's 2 times 15? That is 30. Now we're just solving. We're going to distribute. So 5 times X is 5X. 5 times negative 2 is negative 10 equals 30. Solve for X, we add 10 to both sides. So we get 5X equals 40. Divide by 5. We get X equals 8. Now what was X? What was X? Well, X was this entire length right here, right? So we know that JH, we're looking for JH? We are. We know JH, JH is going to equal 8. We just solved for that. What is JL? Let's see what JL is. Well, JL is this part right here, which we talked about, which is actually Y, which is X minus 2, right? So y equals, well, x is 8, so 8 minus 2 is 6. So we know that JL is going to equal 6. And there's our answers, okay? All right, sounds good. Okay, why don't you guys go ahead and try the checkpoints, and I'm going to leave it zoomed out so you can see what we talked about. So in example 1, you're going to find this value of x, and then in example 2, you have a new proportion here. So make sure you guys kind of follow the new proportion. Go ahead and pause the video, see how you do. Okay, well the original, we can just use the original proportion here for example 1, which was 12 over 18 equals 9 over x. Okay, so we're just solving this proportion. How do we do that? We cross multiply, so we have 12x is going to be 12 times x is 12x. 18 times 9 is 162. Divide by 12. And we get x equals, and what's that's going to be 13.5. It's kind of weird that it's decimal, but that is the answer. All right, the setup for this one right here, if we do the same thing but a little bit different, we have KL over GH, okay? KL over GH. I'm going to call GH Z. We don't really know what that is right now, okay? So KL is 12 over, what's GH? Well, that's going to be Z, equals JK, which is 15, over, then we have let's see here, JG. Okay, this is a little bit trickier. We have JG. JG is this distance right here. Well, what two things make up JG? Well, we have 5 and 15. What's 5 plus 15? That is 20, okay? So that's why it's important to look at what it's asking here. All right, now we just got to solve this. We're going to distribute, or sorry, we're going to cross multiply. So we have 15z. 12 times 20 is 240. Divide by 15. We get z equals 16. So, and that's not just z, that's actually GH. And I want you to find GH's over here. I forgot to mention that. GH equals 16. All right, sounds good. Okay, so that's how you work with proportions here, all right? So let's go ahead and talk about example 3 now, which is finding scale. So the scale of a drawing, basically like, you know, if we're looking at like maps, we don't make a map like real distance, right? If you're looking for the map like of Wisconsin, to make an actual map of Wisconsin, the actual, you know, the actual size of Wisconsin would not be appropriate because it would be as big as Wisconsin. So scale is basically like taking like an actual distance and making it proportional, making it much smaller so you can actually like kind of get the actual distance based on a scale. So, okay, so let's talk about this here. So let's, example 3, we have the length of a key in the scale drawing is 7 centimeters. The length of the actual key is 4 centimeters. What is the scale of the drawing? Okay, so here's what we're going to do. To find the scale, we're going to write a ratio. And what I like to do for a ratio is I like to do the model or the scale over the actual size, okay? And what I like to do, and then rewrite the ratio so that it has a 1 as a numerator or denominator. And what we want to do is we want to divide both by the smaller number. Divide both by the smaller number. You'll see what I mean in a second here, okay? All right, so let's go ahead and do that. So we're going to do model or scale over actual. So what's the model or scale distance in this problem here? Well, since the scale drawing is 7 centimeters, so we have 7 centimeters. Oops. 7 centimeters is the scale drawing. What's the actual size of the key? It is 4 centimeters. Okay, so now what we're going to do, the centimeters are going to cancel, but we need to make it like a 1 for one of these values here. Which number is smaller, 7 or 4? 4 is smaller, so we're going to divide top and bottom by 4, and that's going to give us a something to 1 ratio, which you'll see in a second here. So 7 divided by 4 is going to be 1.75, and 4 divided by 4 is going to be 1. So the scale, where we have a 1 in it, is going to be from 7 to 4 is 1.75 to 1. And that's how you get an actual scale. So for scales, you want like a 1 in like one of the either top or bottom of this, okay? All right, why don't you guys go ahead and try example 3. Just change this from 6 meters to 6 centimeters. And I will zoom back out so you can see what we did here, okay? Why don't you guys try checkpoint 3? Go ahead. All right, so checkpoint 3. It says in example 3, suppose the length of the key in the scale drawing is 6 centimeters. Find the new scale of the drawing. So we're talking about the same example. So what's the scale drawing for this problem? Well, it is a scale size, that is. It's 6 centimeters, and the actual size of the key is 4 centimeters. Okay, so centimeters are going to cancel. What's the smaller number, 6 or 4? We're going to divide top and bottom by 4 to kind of cancel out and give us a 1 for either numerator or denominator. And 6 divided by 4 is 1.5, and 4 divided by 4 is 1. So the scale is going to be 1.5 to 1. All right, sounds good. Next example, let's talk about, we got a few more examples to do here. Now we're going to actually use a scale drawing, okay? So it says the scale of the map at the right is 1 inch equals 8 miles, or is 8 miles. And find the actual distance from Westbrook to Cooley, okay? So this distance right here from Westbrook to Cooley is going to be 1.25 inches. Okay, if you were to measure that like using a ruler, okay? So what we're going to do is we're going to set up a proportion. We're going to also, I would always encourage you to do model over actual just to get in the habit so we don't confuse anything. You can flip proportions any way you want, but it's just going to be a good idea to do this here, okay? So what's the model to actual distance they gave us originally here, okay? I'm going to go model to actual. What's the model to actual distance we know for one of the things here? Well, we know that 1 inch is 8 miles. What number is the model size? 1 inch, right? So 1 inch is the model size over, what's the actual size on the map? So 1 inch is actually 8 miles, okay? And that equals, all right? And we're looking for the actual distance from Westbrook to Cooley, okay? Do we know the model or scale size of the distance? Well, yeah, we know that's 1.25. So 1.25 is the model distance. And we don't know this, we're going to put X miles for this down here, okay? All right, now we have a set of proportions. How do we solve proportions? We cross multiply. So we have 1 times X is X. And then we have 8 times 1.25. And what is 8 times 1.25? That is 10 miles. And that is going to be the actual distance based on the scale. Okay? All right, so checkpoint 4. Checkpoint 4 is, we're just finding an actual scale, okay? You're just finding a scale. It's not like the last one we did, but it's kind of more like example 3. So why don't you guys pause the video, see if you can do checkpoint 4. Go ahead. All right, 2 landmarks are 130 miles from each other. The landmarks are 6.5 inches apart on a map. Find the scale of the map. So again, we're always going to try to do model over actual to keep things organized. Model over actual. So what's the model size? Is it 130 miles or 6.5 miles? Or inches, I mean. 6.5 inches is going to be the, that's the scale size. What's the actual distance? 130 miles. Okay. All right. Now we want a scale, so we want to divide by the smaller number here. What's the smaller number? 6.5. Even though, like, if these, like, units were flipped, it would still be different. It would still be, like, this would still be the smaller number. 6.5 would still be the smaller number, but just keep that in mind. You divide by the smaller, like, number in the actual fraction. So we're going to divide both sides by top and bottom by 6.5. Divide by 6.5. And 6.5 divided by 6.5 is going to be 1 inch. And 130 miles divided by 6.5 is going to be 20 miles. So for this map, the scale of the map is going to be 1 inch is 20 miles. All right, we got 2 more examples to do here. Let's keep moving. All right, so solve a multi-step problem. You buy a 3D scale model of the Sun Sphere in Knoxville, Tennessee. The actual building is 266 feet tall. Your model is 20 inches tall, and the diameter of the dome on your scale model is 5.6 inches. What is the actual diameter of the dome? Okay, so again, we're going to do model over actual. Okay, so we're going to set up a proportion here based on the information that we know, and we are going to try to solve for what we're looking for. All right, so we have both the height of the building and we also have the diameter of the dome. So let's start with the height of the building. What's the model size height of the building? Or what's the height of the model? The height of the model is 20 inches tall, right? So we're going to do 20 inches is how tall the model is. How tall is the actual building? It is 266 feet. So we're going to do 266 feet equals, now we can talk about the diameter of the dome. Do we know the diameter of the model? Yeah, it's 5.6 inches. Over, do we know the actual diameter of the dome, or is that what we're looking for? That's what we're looking for, so we're going to call that x feet, okay? Now we can do our solving. We're going to go ahead, we're going to cross multiply, so we have 20x equals, if you multiply 266 times 5.6, you're going to get 1,489.6 that. Then we divide by 20 to solve for x. We get x is going to be equal to 74.48 feet. And that's how wide the actual, the diameter of the actual dome is going to be, okay? And diameter of a diameter is like straight across, like usually a circular type shape. Okay, so let's go ahead and do this here. So for B, it says how many times as tall as your model is the actual building. So this is a little weird because we have two different units here. We have inches and feet. So what we're going to need to know to actually do is we're going to need to convert feet to inches, these feet to inches, or these inches to feet, or to, yeah, these feet to inches or these inches to feet. So let's convert the feet to inches. We're going to use our dimensional analysis like we talked about in the last thing. So we have 266 feet. We're going to make our little bracket here over 1. Now we're going to convert feet to inches. Okay, so if I want to cancel feet, well, how many inches are in a foot? We have 12 inches per foot. Now where should I put feet if I want to cancel them? I want to put them down in the bottom here. So 1 foot, I'm going to put feet down here to cancel the feet. And we have 12 inches. So 266 times 12 we multiply across the top is going to be, oh wait, something's weird here. Oh, I'm sorry. So we have, something's weird. Okay, I goofed up. So we're going to, let me see if I can erase this. So we're going to actually do, I forgot to do it. We're going to do 266 feet. No, we're good. Actually, this is fine. I don't know what I was doing here. So we have, this is going to equal 3,192. Okay. And now what we can do, this is going to be inches. That's how tall the actual building is. So now what we can do is we can go ahead and we can compare how many times as tall the building is to the model. So how do we do that? Well, we're going to divide the actual building, which is bigger, 3,192, and we're going to divide by 20, and that's approximately 159.6 times as large. Okay, so you're trying to figure out how many times as large something is. You do the bigger number divided by the smaller number, and this will be like how many times bigger it is. Okay, so that's how many times bigger it is. All right, sounds good. Okay, do you have checkpoint 5 as the last example? It is very similar to what we did for example A, except now we're going to have a 5-inch tall model. So why don't you guys pause the video to see how you do. All right, so your friend has a model of some sphere that's 5 inches tall. What is the approximate diameter of the dome on your friend's model? Okay, so let's set this up here. So we're actually comparing, in this case, we're comparing the model to the model, okay? This one's actually a little weird. So let's see here. So 5 inches tall. Yeah, we're actually, I forgot to mention, this one's kind of weird because we're doing the one model to another model, okay? So it's kind of weird. So we're going to be actually measuring height over height and diameter over diameter, all right? So let's go ahead and do that. So what's, the new model is going to be 5 inches tall, right? So we have 5 inches tall. How tall was the other model we had here? Well, it was 20 inches tall, okay? And that equals, do we know the diameter of the dome of our friend's model? We do not. We're going to call that x. And the diameter of our actual model we know is going to be 5.6 inches. Okay, so we're going to go ahead, we're going to cross multiply. So we have 20x equals 5 times 5.6 is 28. Divide by 20. We get x is equal to 1.4 inches. So this one's kind of weird. I got thrown off by this, but basically you're comparing, it's still like model to actual kind of, but we're comparing like height to height and diameter to diameter. You can also do that as well. I wouldn't worry about that one too much, though. Otherwise, you'll be in good shape. Okay? All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.